Well, my parcel's arrived and it's time to get into this NSR Baby King 17,000 RPM motor. This is the spec motor for my upcoming race. It's not a motor or a brand I've ever used. The one you've seen me build into the motor pod is a scale auto, and this one's different. The can design, it's got a large oval hole in there instead of two, or is it three circular holes. This one states the effect, states magnetic effect on there. 17,000 RPM, 245 grams centimetre. Let's compare that, because I know there's some specs on this one too. 18,000 RPM, 310 grams centimetre. So that suggests that this one will be a bit slower than this one. These are not slow. There's plenty of go in those, even on the big tracks that we race. So it's time to pay our attentions to this. I can see a little bit more inside of this one. In fact, I can see a lot more. I can see the commutator, I can see the motor brushes. Oh, there's a little bit of wine, there's a little bit of balancing. There's a little bit of epoxy in the armature stack just there. Right there, a little bit of black putty looking stuff. That's normally put there to balance. Oh yeah, there's some more. There's some more here and here. And none at all here and here. That's good. That means it's less likely to vibrate too much when it runs. Anyhow, first things first, it's motor preparation time, and I'm going to put this motor in this way up. That's just an executive decision. I don't think it's going to make a difference. There is actually one check I can do, but I'm going to take my bar and just put a 45-degree bend on the tabs, because I know that these are going to get in the way of the suspension. Yeah, I've just bent those up, not even 45 degrees, 30 degrees, just to make them a little bit shorter. And the next thing I need to do is get some solder on there. And what do you know, my solder's not here. Found my solder. Wrong drawer in the pit box. Anyway, got my tiny little iron on. Don't want to do too much heating of the brush hoods, the electrical contacts between here and the commutator, so we'll do a little bit of tinning of the iron and just get some solder on the end. Iron on there for no more than 3 or 4 seconds. And next I'm going to bring this into the equation. This is a socket for a barrel plug. I bought these on the internet auction site. They've got screw terminals. You allow me to just chuck a couple of, well, these are slotted braid wires. Going to get some connections onto this. We're not proud of this soldering. It doesn't have to be showroom standard. Just enough to make a connection. Then we'll bring in secret weapon. Power supply unit. Now, I don't know whether I've showed you this before, but these are relatively inexpensive. They come from AliExpress. I managed to get one with a UK plug on it, but it comes with this female barrel connector. You might call it a male, but there's actually a socket in the end of there. I don't know. Let's call this a female. Let's call this a male. Let's call it a male. Yeah, it's going to plug in. And I'm going to plug that into there. Tidy up a bit. And then this is the minimum voltage that mine will output, 3 point something, just below 4, 3.7 something. Which way is the motor running? It's running the way it's going to race in the car. So now we've got that. I'm going to bring this into the picture. Regular drinking tap water. Get a little creative with a screwdriver. Allow that to submerge and give it time. Exactly how long? Well, that's different for different motors. This is an old-timers technique. The water in there is going to lubricate a little bit between the commutator and the brushes. It's also going to reduce the sparking between the commutator and the brushes. So now the motor can just run and run and run. The brushes will bed into the shape of the commutator because the commutator will wear them. And the trick I tend to use is to watch the colour of the water. If your motor brushes are particularly soft, then the water will turn grey really quickly. It turns a grey-silver colour, and you'll see that. But if I'm not mistaken, these FK style motors like this one, they'll run for quite a long time. Yeah, the commutator's submerged and there's no... It's quite interesting to watch the bubbles come away from the motor. Armature throwing bubbles out that hole. In the opposite direction on the other side. So yeah, that's the solution for motor braking. I'm yet to come across anything else that's better. We'll just leave that and let that run. Well, in this case, it didn't take long at all. Looking in there now, and I know you won't be able to see, but it looks like the brushes have got shorter. That's just from my memory of how long they looked before I started the process. And the water, well, the water's turned quite black, which suggests that I'm not going to be drinking any of this anymore, but it suggests that the motor brushes were quite soft in this can, in this particular spec. The only thing we have to do now is let that dry, and then we'll do some evaluation. I'm just looking for sparks at the brushes and commutator. We've got that on nearly 8 volts right now. Seems quite smooth and vibration free. That's 12 volts. And now it's telling me it needs lubricating. As it's drying out, it's making a different noise. So we'll cut that for now and we'll let that dry. We'll give it a little lube and see what we've got. Okay, back to this view for a next step. I've got the motor taped to my build plate, and this is a servo horn from a micro servo from a radio control toy. It's got a piece of reflective tape on this side, and this side's just black because I decided to black it. So we'll get this motor running, and I'd like to show you this app that you can get. It's not easy to find, but it's called Giri, which is the Italian word for revs. It's an RPM checking device, and it uses the mobile phone's microphone (2,420 RPM). And then we've got this device, digital tachometer, which is capable of reading that spinning reflective. Doesn't quite have to be this close. So the Giri app's telling me 10,000 RPM all of a sudden. Wonder if it can hear the not a propeller, but that thing going around twice. Anyway, we'll test this out. Turn this up to 4 volts. That's 4.00 volts precisely. I'm not sure why Giri is measuring exactly twice. Motor seems quite smooth. So it was 5,600, so double that would be 11,200. You're getting 5,006 from Giri now. Anyway, let's double the voltage up to 8. My voltmeter is reading to 2 decimal places, so to hit it exactly on 8 is very, very gentle with that knob, because it makes a huge difference. 8.00. Jerry's saying 11,700. and change. I'd say that we're working pretty well. Now the motor's a bit louder. My voice is not even affecting the app. And that's almost exactly twice the RPM that we're getting at 4 volts. So now let's go up to 12. .1, 12.2, I'm a little bit above. .0, 18,000 RPM on Jiri. Oh, I saw a spark. Motor was starting to dance on the plate there. Still 12.0. Oh, you can't see that. $18.1 thousand. I'd say Jiri works rather well if all you've got is a mobile phone. So yeah, that's a 17,000 RPM motor doing 18,000. I don't know whether that's good, bad or indifferent, but it is what it is. I've only got the one. We'll have to go and put that thing in and see what we've got.